Today we're going to talk about Lesson 20, adding and subtracting rational numbers. Before we actually begin into the steps for adding and subtracting fractions, we want to talk about common denominators. This is one of the most important skills that students are going to need to know how to do. It's the ability to replace fractions with different denominators that represent equal denominators. We want to first talk about finding the least common denominator. The least common denominator of two fractions is the least common multiple of their denominators. So you should be teaching your students to list out the multiples at first, and then you're going to find the least common multiple. That would be your least common denominators. We're going to look at some examples. The directions for example 1 says, identify the common denominator for each pair of fractions. Then replace the fractions in each pair by equal fractions having the smallest common denominator. Let's look at example A, 3/4 and 2/5. If I list out the multiples of 4, 4 times 1, 4 times 2, 4 times 3, 4 times 4, and 4 times 5, we get 4, 8, 12, 16, and 20. And then I'm going to do the same thing for 5. 5, 10, 15, 20. That's 5 times 1, 5 times 2, 5 times 3, 5 times 4. The first multiple that they have in common is 20. That is the least common multiple of 4 and 5. It is also the common denominator. So then we're going to convert these fractions to common denominators. So if we look at 3/4, we can ask ourselves, what do I multiply 4 by to get 20? And that is 5. So I'm going to take and I'm going to multiply my numerator 3 by 5 as well. So 3 times 5 is 15. So an equivalent fraction to 3/4 with a denominator of 20 is 15/20. You see that when I multiply 3/4 by 5 over 5, 5 over 5 is 1. So when I'm multiplying 3/4 by 1, I'm getting an equivalent fraction. What do I multiply 5 by to get 20? That would be 4. So 2 times 4 gives me 8. So 8/20 is equivalent to 2/5. If we look at number B, I have 7/12 and -3/8. If I look at the multiples of 12, 12 times 1, 12 times 2, and then the multiples of 8, 8 times 1, 8 times 2, 8 times 3, we see that the least common multiple of 8 and 12 is 24. So if I wanted to convert 7/12 to a denominator, an equivalent fraction that has a denominator of 24, I would say 12 multiplied by 2 gives me 24. So 7 times 2 would give me 14. So 7/12 and 14 over 24 are equivalent fractions. To convert -3/8 with a denominator of 24, I'm going to multiply by 3 over 3. 8 times 3 is 24. -3 times 3, -9 over 24. In C, if we look at the least common multiple of 6 and 18, you can see that we get 18 as our least common multiple. That is my common denominator. So to convert 1/6 to a fraction that has a denominator of 18, I'm going to multiply by 3 over 3. 6 goes into 18 3 times. 3 times 1 is 3. 5 over 18 already has the common denominator of 18. Basically, it does not change. We're multiplying it by 1. It is important to know about how to find common denominators because that is important when we're adding fractions. But first, we want to talk about adding fractions with like denominators. When we add fractions with like denominators, we simply add the numerators, place that sum of the numerators over the already common denominator. As always, when we're dealing with fractions, if we need or if our fraction is not in lowest terms, we want to reduce if necessary. So a simple example, if I was adding, like in example 2, 3/5 plus 1/5, then I would keep my denominator of 5. It stays the same. And I add my numerators. 3 plus 1 equals 4. So we get 4/5. 4 and 5 are relatively prime. Remember, that means that there is no factor other than 1 that I can divide 4 and 5 by. So that is my final answer. When we have unlike denominators, it's a little bit different. We first have to convert each fraction to an equivalent fraction that has a common denominator. Remember, the common denominator is the least common denominator or the least common multiple of the two denominators that we have. We cannot add fractions unless we have a common denominator. So let's look at an example. In example 3, I want to add 1/6 plus 3/4. We do not have a common denominator. So the first thing we're going to do is we're going to find the least common denominator of 6 and 4. To do that, we can look at the product of primes. This should say, instead of 22, that should say 2 times 2. Or 2 squared. This is looking at our product of primes. 4 equals 2 squared. So our least common denominator would be 2 squared times 3. You can also think about that as multiples of 6 and 4. The first multiple that they have in common is 12. If I wanted to convert 1/6 and 3/4 to a common denominator, I'd say, what do I multiply 6 by to get 12? That is 2. So 2 multiplied by 1 gives me 2. What do I multiply 4 by to get 12? 3. So 3 multiplied by 3 gives me 9. So we convert the things that do not have common denominators to equivalent fractions with the least common denominator. Once we have like denominators, we simply add the numerators and keep that like denominator. So 2/12 plus 9/12 gives me 11/12. Since 11/12 is already reduced, we're done. But we always want to remember to check our final answer and make sure that the fraction we have is in lowest terms. Let's look at some other examples. Here we're adding fractions with like denominators. To start off with, 4/5 plus 3/5 gives me 7/5. I keep the same denominator, that's like, I add my numerator. Example B, 2/9 plus 6/9 gives me 8/9. I already have the common denominator, I keep it, I add my numerator. For 1/2 and 1/3, we need to convert this to our common denominator of 6. 6 is the first multiplication fact that 2 and 3 have in common. 2 times 1, 2 times 2, 2 times 3, 3 times 1, 3 times 2. So what do I multiply 2 by to get 6? 3. So 1 times 3 is 3. What do I multiply 3 by to get 6? That would be 2. So 1 times 2 is 2. So an equivalent fraction to 1/2 that has a denominator of 6 is 3/6. An equivalent fraction to 1/3 with a denominator of 6 is 2. Now that I have like denominators, I keep the like denominator and I add my numerator. 3 plus 2 equals 5. So I have 5/6. Both 5 and 6 are relatively prime. There's no number that I can divide 5 and 6 by. So that's our final answer. All right, so let's look at D. D, we have 4 and 7. The first multiplication fact that they have in common is 28. 4 goes into 28 7 times. 7 times 1 is 7. 7 goes into 28 4 times. 4 times 3 is 12. So 7 plus 12 is 19/28. Again, I cannot reduce 19 over 28, so I'm done. The last example, E, we're going to get a common denominator of 24. 6 goes into 24 4 times. 4 times 5 is 20. 8 goes into 24 3 times. 3 times -1 is -3. So I'm going to keep my denominator of 24. 20 plus -3 gives me positive 17. Again, 17 over 24 is reduced. There's no number other than one that I can divide 17 and 24 by evenly. Let's talk about how we add mixed numbers. There are two different ways that you can do it. You can add the whole numbers and then add the fractions separately. You're going to look at examples where you're going to want to do that first because it's going to be really easy. However, sometimes if when you add those fractions separately, you get an improper fraction and you have to convert that to a mixed number, it's very much doable that way, but sometimes it's often easy to use the second method. The second method is to convert a mixed number to an improper fraction. Then we're going to follow our addition rules to add, and then when we get our final answer, we can convert it back to a mixed number. Either of these ways works. Example 5, we're going to look at 3/2 plus 5 2/3. In this example, I just went ahead and converted the mixed numbers to improper fractions. So 3 1/2 becomes 7/2 because 2 times 3 is 6 plus 1 gives me 7. I keep it over my common denominator of 2. 3 times 5 is 15 plus 2 gives me 17. I keep my denominator. 5 2/3 becomes 17/3. Then I get a common denominator of 6. 2 goes into 6 3 times, or what number do I multiply 2 by to get 6? That would be 3. It's another way that you can word that. 7 times 3 is 21. 3 multiplied by 2 gives me 6. So 17 multiplied by 2 is 34. I keep my common factor, or my common denominator of 6. 21 plus 34 is 55. And then I divide that out. 55 divided by 6. So 6 goes into 59 9 times. 9 multiplied by 6 is 54. I subtract that, and I get 9 1/6 as my final answer. The rules for subtracting fraction. The rules for subtraction of fractions are very similar to that of the addition of fractions. In other words, when you subtract two fractions, the denominators of those fractions must also be the same. So when you're adding and subtracting, you have to have common denominators. Let's look at example 6, where we're asked to subtract the following fractions. If I wanted to subtract 7/8 minus 1/3, I need a common denominator. That common denominator, the least common multiple that 8 and 3 have in common, is 24. What number do I multiply 8 by to get 24? That is 3. So 7 times 3 is 21. What number do I multiply 3 by to get 24? That is 8. So 8 times 1 is 8. So I keep the common denominator of 24. 21 minus 8 in my numerator gives me 13. Then I check to see if it's reduced. 13 over 24 is reduced to the lowest terms. So that's the answer to my problem. A second example would be 1/2 minus 4/5. You can see I got a common denominator of 10. I get 5/10 minus 8/10. I keep my common denominator of 10. 5 minus 8 gives me -3, and -3/10 is reduced. So we're going to follow the same rules as with addition. Let's work an example where we subtract mixed numbers. Again, you can work them either way. To me, the easiest way is to go ahead and convert those fractions into improper fractions and then work from there. The only difference between adding mixed numbers and subtracting mixed numbers is the subtraction symbol. You're going to follow the same directions. I do want to share with you a neat way that you can add and subtract fractions. It's using the butterfly method. So you're going to see that I have this example up here in the top right, that as we talk through the rules, you're going to see how that example shows these steps. Step 1, you're going to write the fractions side by side as usual. And you draw 2 diagonals. You can see here where we have drawn a diagonal between the 6 and the 2 and the 4 and the 5. This is going to be the wings of our butterfly. Then you're going to draw an antenna on each wings. So here's my butterfly wings. And then you draw an antenna on each wing. It says, as suggested by the wings that look like a multiplication sign, you multiply the numbers in each wing. So 6 times 2 is 12, so you put it in that antenna. 4 times 5 is 20, you put it in that antenna. Thinkers say, this poor butterfly needs a body. So to give it a body, you connect the bottom parts of the wings. You can see that I multiplied those together. You multiply the 2 denominators it connects, and you put that product inside the body. You're going to add or subtract the numbers in the antenna in keeping with what is being done to the fractions. So since this is a subtraction, 20 minus 12 gives me 8. I multiplied 6 times 5 and got 30. I get 8 over 30th. Add or subtract the numbers in the antenna and put the result over the number in the body. We get 8 over 30, and then we reduce that. So I can divide both of those by 2. 8 divided by 2 is 4, and 30 divided by 2 is 15. This is a neat way of adding and subtracting fractions. The only difference in subtracting fractions versus adding them is that last step where the numbers in the antenna are either subtracted or added. Let's look at an example of the butterfly method. We're going to add this using the butterfly method. So you can see here that I've drawn 2 diagonals for the 4 and 3 and the 1 and the 7. Then I drew my antennas on top of my butterfly, and I multiply those diagonals. 4 times 3 is 12. 7 times 1 is 7. Then I add my body, so I added my body, and I multiply those 2 denominators together. 4 times 7 is 28. So you're going to put, the bottom is going to be the body. That's your common denominator. That's 28. And since I'm adding, I'm going to add what's in the antennas. 7 plus 12 is 19. So my answer is 19 over 28. I make sure that is reduced. It is. 19 and 28 are relatively prime. There's no number other than 1 that I can divide both of them by. So I'm done. My answer is 19 over 28.